In those super regulated industries, change control is, well, it's everything. But what do you do when the system is literally built to change? With AI, that constant evolution, it's not a bug, it's the main feature. So let's get into how we can actually manage all of that. This is a question that kind of shakes the very foundation of how we've always done software validation. I mean, for decades, right? We've all been taught that the code is the one and only source of truth for how a system behaves. But what happens when that's just not the case anymore? Yeah. And for AI systems, this is the new reality we have to get our heads around. If you've got an AI working in a GXP environment, that's all those good practice rules for pharma and other industries, change isn't a possibility, it's a guarantee. The whole game isn't about stopping change, it's about building a system that can see it, understand it, and most importantly, govern it. Okay, so first things first, let's really break down why this is so completely different from the traditional systems we're all used to. The nature of AI itself means it's pretty much always in a state of flux. Now, what's fascinating here is that all of these changes can happen completely independently of any new code being pushed out. You could have a model get retrained on fresh data, or maybe the data it's seeing out in the wild starts to drift away from what it was trained on. Or, hey, maybe users just start using the thing in ways nobody ever expected. The bottom line, though, is that all of this stuff affects how the system behaves. And in a regulated space, well, that kind of unexamined change is a direct path to some serious risk. So, what's the solution? How do we possibly deal with this? Well, you don't try to lock the system down and keep it static. That's a losing battle. Instead, you build a framework, a smart one, that makes every single change visible, intentional, and totally under control. And this diagram, it does a fantastic job of showing the solution, what's called an IT/OT control plane. Basically, it breaks the system down into 3 distinct layers. Way down at the bottom, you've got your evidence and audit plane. Then in the middle, that's the execution plane. That's where all the action happens. And sitting right on top of everything is the control plane. Think of this as the brains of the operation, the governance layer, where we set all the rules, create the approval gates, and really manage change by design. So you see, when we're talking about change management for AI, we have to think bigger. We've got to expand our definition. It's not just about the code anymore. It absolutely has to cover model updates, tiny tweaks to configuration files, changes to the data sources that are feeding the system, and even shifts in how much power or authority the system is given. Ignoring these things doesn't make them go away. It just means they're happening in the dark with zero oversight. But putting a framework like this in place, it's not just a tech problem. It also demands a really, really critical shift in mindset, especially around this idea of revalidation. I mean, for so long, right? Having to revalidate a system was seen as a huge pain. It was a problem, a sign that something broke. But in the world of regulated AI, that way of thinking is completely outdated. Revalidation isn't a failure anymore. It's actually a planned control point. It's not some big setback, it's a safeguard. Honestly, it's the only mature and responsible way to operate a system that is constantly learning and evolving. And this really gets to the core of it. The principle is simple. When a system's behavior changes, we have an obligation to check it again against its intended use. This has nothing to do with pointing fingers at teams or slowing down projects. It's just a fundamental process to protect the business, the product, and, at the end of the day, the patient. Okay, so you might be thinking, does every tiny change need a massive top-to-bottom revalidation? Well, not necessarily, no. The key here is to really understand the system's level of authority. The amount of work we do, the rigor of our response, it has to match the potential impact of that change. It's that simple. So let's say you have an AI system that's just assistive. Maybe it just highlights potential issues for a human to look at. A change there might only need a quick, minimal check. But if that same system has the authority to directly control a manufacturing process, whoa, now any change demands a super formal, super rigorous review and revalidation. That authority boundary is what decides the scope of the work. Let's go back to our control plane diagram for a second. See these approval gates here? This is where that principle becomes real. This is the practical application. These are the specific points in the process where a change absolutely must be formally reviewed. A tweak to a low authority system, it might breeze through a lightweight gate. But a change to a high authority system, that's going to trigger a much, much tougher review. This is exactly how you build a risk-based approach right into the DNA of your system's architecture. And the alternative, well, that's where you get into trouble. A really common mistake we see is people treating a new AI model like it's just a simple software patch. They just assume, oh, it's new, so it must be better, without actually verifying its performance against what the system is supposed to do. And that, my friends, is a fast track to audit findings and some pretty scary operational risks.
All right, this brings us to what might be the most important part of this whole thing. You can't just slap change management on at the end and hope for the best. You have to design for it from day one.
So a truly robust, change-ready AI system, it's built on these 4 pillars. It's always, continuously, capturing evidence of how it's performing. It has explicit versioning, and I don't just mean for code, I mean for the models and the data too. It has a tested, working way to roll back to a previous version if things go sideways. And finally, change management is baked right in, not just some paperwork you do after the fact. And if we look at our diagram just one last time, you can see these critical safety nets are designed right into the system. Those emergency rollback and revert paths, they are not an afterthought. They are planned, they are engineered functionalities that let operators safely hit undo on a change that had some unintended consequence. This, right here, is what designing for the inevitable really looks like. Okay, and just to be crystal clear about what we're doing here in this explainer, what we've done is lay out the foundational principles for managing how AI evolves, especially in a regulated space. This is all about getting you and your teams ready to think about this challenge in the right way. But, and this is important, this is not a specific regulatory procedure, and it absolutely does not approve any specific system or change. That's a job for your own quality and regulatory teams to figure out. So I want to leave you with this final thought. Change for your AI systems is not a matter of if, but when. It's going to happen. The only real question you have to ask yourself is this: is your AI system actually designed to evolve safely, or is it just waiting to become an audit finding?